Hey, how you doing today? Mr. Hardy here. We are getting ready to continue in our linear equations unit here. A little bit more today with solving. Yesterday, just kind of got a little bit used to combining like terms, the distributing, some of the basics and things there. Now we're going to get into the heart of algebra, which is solving stuff. So today, again, note-wise, we are going to be taking a peek at simplifying our answers. Again, a little bit of help with the calculator here. We're going to be chatting a lot about this using Math Enter. We introduced that a little bit yesterday. Let's just jump right on in here, okay? So solving equations with variables on one side. One thing I'm going to mention, I have a lot of people who like to work just off their top of their head. Some people can look at number one and say, well, I can just look at that, Hardy, and know that x is 5. Do I have to show work? My theory with that is yes, at least a step, just because there are going to be problems, like number 2, that you're probably not going to be doing in your head. And so I want to see what your theory is or what your brain is doing, okay? It's kind of like this is the printer for what's going on in your brain, and I want to see what's going on in your brain. So when you're doing these, I'll show you a couple of options I have when I talk about what work looks like. I'll do the most elaborate one first, and then we'll just kind of go from there. So solving equations with a variable on one side. First thing first, what's the job when you're trying to get a variable alone? You're wanting to get the variable term alone first, okay, when we're solving. So we're going to do opposites. Now, you've been talking about opposites enough forever. The opposite of plus is minus. Now, for some of you, it's a little bit of overkill. You're like, really? I got to show that? Can I just at least show you just this? Absolutely. Okay. That's letting me see, oh, they subtracted 7 from both sides. Okay. And then if you want from there, again, opposites. What am I doing next? I'm multiplying because I don't see anything in between. What's the opposite of that? To divide. So for those of you that need to see steps and you need to know this on your own, some of you need to see that. Okay. And that's fine. That's good. Did a good job. For some of you that don't think you need to see that, okay, what you see done in black is at a minimum what I need to see on a problem like this. I do not just want to see answers, especially since within your packet, you have an answer key that gives you answers. I don't want to be wondering, did they just copy the answers down? Because if we start to see that, that's going to bring on a different discussion. So just something to consider. Now, fractions. We're really not going to deal with them that much differently. The theory is still the same. Get the x term by itself. Again, do the opposite, and this is why I like to box them in, the opposite of what's not in the box. So, in this case, that'd be adding 1 to each side. And now you have a choice. You're going to have lots of choices in here. I'm just going to warn you ahead of time. So, if you don't like choices, I don't know who doesn't, but hey. To me, the simplest way is, hey, I'm multiplying by 5 over 2. I don't want to divide by 5 over 2 here because a lot of you don't understand what that actually is meaning, and you're going to want to go to a calculator, and we're going to try, to avoid that as much as possible. So what I can also do is I can multiply by the inverse if I can get my pen to work. That's what happens when you're doing live. There we go. Now, some of you are like, I don't know how to do that off the top of my head. How am I going to get the answer without a calculator? A couple ways. One would be remembering that we're multiplying by what's on top and dividing by the bottom. 20 times 2 is 40, divided by 5 is 8. Another option we have, if we are going to go to a calculator, would be to do 20 times 2/5. It's important for the most part to put your fractions in parentheses if you're using the TI calculator, okay? If you don't, sometimes you'll get away with it, sometimes you won't. So we got to think about that. I still get 8, okay? But here's my last option. If you are a one step at a time person and you're on this step, here's one other thing you could do. You could say, hey, I don't like fractions, So what's the opposite of dividing by 2? Because that's what this is. I could multiply both sides by 2. 5x equals 40. And then, oh, what's the opposite of multiply by 5? Divide by 5. Excuse me on the bump there. I get the same answer either way. So either of those is going to work. Okay? So again, math, a lot of times we get options on things, but we got to get the practice to be able to know what those options are going to look like. Okay? So that's solving equations with variables on one side. If we step our game up a little, solving equations with variables on both sides. Ooh. How do I determine what to do first? There's really not a wrong place. What I typically do, though, is I like to get all of my variable terms together first. Since they're on opposite sides of the equation, and sometimes I almost like to look at it like there's this imaginary wall here. If my variable terms are on opposite sides of the wall, I got to do an opposite to get them together. I also like keeping my variable terms positive. Now, some people like always having them on the left. It doesn't matter, however you want to do this. So what we're going to do here, in my case, is I want to keep my a's positive. So I'm going to go ahead and I'm going to subtract my 3a from both sides. So on the left, no more a. Don't lose your equals. 9 minus 3 is 6a. And now the problem looks a lot like what we were dealing with in 1 and 2. Because once I get here, now it's about, okay, I have one variable term. I want to get it alone. What do? I do the opposite of what's outside of it. The opposite of minus 8 is the plus 8. And the opposite of multiplying a by 6, because again, here's what I'm trying to get by itself. Now, 21 over 6. Reminder here. We always want to get terms in their simplest form. So if you get a fraction for an answer, I would suggest you do 21 divided by 6. Now, if you hit enter, you're going to get a decimal. Decimals, we don't like doing because when we do get to standardized testing, hopefully later this year, for those of you that would be thinking about moving on in your education, like 3.5 is not going to be an answer that's sitting there on the SAT. 21 over 6 isn't either. So now remember, up at the top of your page, it says, hey, simplified. We do math. Get math up here. There's math. And then you just hit enter twice. And what that's going to do is give you the simplified fraction form of your answer. That's what would be on a testing type unit. That's when we start to do some assignments and quizzes on online resources, you're going to have simplified answers. Because not every program is going to look and say, oh, 21 over 6, that's fine. Ooh, it should be 7 over 2. Now, Mr. H might see it later, but when you're initially taking it, you're probably not going to see that necessarily. Okay. We might get a little distributing in there with it. And while I'm writing in my distributing, I'm going to say this through the first few videos that we do. If after watching these and practicing, and maybe going back and looking at a couple of the ones you're struggling with again, and leave your notes out when you're actually working on these. Perfectly legal to do, perfectly smart thing to do, especially when you're learning something. If you're still having issues, email me. Or if you're in class, ask me, okay, with questions, so we can make sure we've got you on a good track. Don't wait until things are going bad. When we distribute, we multiply. So 4 times 3 is 12. 4 times 1 is 4. Make sure you don't lose your x. And again, the more you can visually see, that's why I even draw my arrows here, the better off you're going to be. So now I got all kinds of issues. I got x's on both sides. I got x's together over here. My suggestion is always, if you have variables on the same side of the equals, okay, we're going to deal with those differently. I'm not going to plus 7x to both of these. Now, if I was trying to do it to both sides, I would. But if they're on the same side of the equals, we just combine them. 10 minus 7, I still got to watch my signs. Now we're back looking like we were in number 3. And again, it's my choice. I like to keep my x's positive, so I'll usually move the smaller value. And now we're getting into that area where things should be simpler for us. Should be able to get our x's alone, do the opposite of what's not in the box. And I can't say enough for those of you that are a little more comfortable, just seeing what you see with the black ink here is perfectly fine to show for work. Divide by 9. Make sure I'm writing this where my head is not getting in the way. Okay, and x is going to equal 4. And we're going along with that. So not bad. Okay, not bad at all. So again, as long as you take your time, it's stuff you've been seeing for a couple of years now, shouldn't be too bad. Proportions. Cross multiply. Let me add one little part to this. If there's only fractions on each side. Okay? The first two are what I'm talking about. Just one fraction on each side. We can cross multiply. That's a perfectly good idea. Number 7 going to be a little different. We'll chat about that when we get there. So here I look, okay, cross multiply. Now, a reminder on what cross multiplying is, if it's been a little while. Some of you have heard this little butterfly thing before and other things. It just means we're going to make an x out of this. So 7 times x is 7x. 3 times 10 is 30. And now we just solve what's left, which in this case is dividing by 7. Again, avoid the decimals. 30 divided by 7. It's a decimal, though. We know our rule, though. Math, and again, if you're using a different calculator, again, you'll have a fraction button. Enter, enter. It's still 30 over 7, so this one didn't reduce. That's just my answer. Now, number 6. Okay, number 6, I'm going to put 1 star next to, because there is a little catch to this one that we got to be looking out for. When we start getting binomials, again, more than one term in there, we want to make sure we put parentheses around them at the start. Why? Because if I go to cross multiply and I didn't have those parentheses there, I would think it was just 4x minus 3, but that's not what it is. It's 4 times x minus 3. That 4 is going to get distributed to both of those terms. And if I didn't put the parentheses, I'm probably going to forget that. I know I would. And then on this side, 6 times the quantity x plus 2. Not just 6x plus 2. Major difference. So I do my distributing. Other cool thing about videos is sometimes I get a little excited, as you can tell. Voice inflection goes up and down, but I also tend to start getting on a roll and I go faster. If I'm going a little bit quick for you, you can just pause me or rewind me until you get where you want to be. So you get distributed. Now we're right back to what we were doing up in top. Get all my x's to one side. Again, how you do that is up to you. If you did minus 6x, perfectly fine. Just make sure your equal stays there and that your terms stay on the same sides they were at. Like I can't all of a sudden move this 2x over to this side. That's not legal. Everybody stays on the sides where they're at. Make sure that equal sign's your guide. And now again, we're just back to, hey, I want to get my x term alone. So, do an opposite. If sometime you're not sure, negative 12 and negative 12 do not cancel. If I owe somebody $12 and I owe them 12 more, my debt didn't get canceled out, even though that'd be nice. Now I owe them 24. And I divide by 2. I'm good. Okay. So it can take a little more work, but again, just let me see some steps, and as you get more comfortable, you might be able to skip some more steps. Okay, finally, oh boy, what do I do here? Okay, first job on number 7. Okay, star, get fraction alone first. Okay, don't try to do something fancy here. You can't cross multiply. Don't multiply everything by -5. Why not, Hardy? Because if you do, most people forget it would have to be all 3 terms. They forget about the 4. By getting the fraction alone first, getting that 4 out of there, now, if I think about it, I'm like, okay, what else is in my way? What's keeping me from getting to that -2x plus 10? Because the stuff that's bonded together is going to have those stronger bonds that I can't divide until I get there. So here, I need to take care of this next. I need to take care of divide, that's what a fraction is, divide by -5, which would be to multiply. Okay. And now we're back to normal. Well, at least what we think of as our normal here. Now the goal, get the x term alone. Get that 10 out of there. Always about the opposites. Divide by -2. And little things here, like negative divided by negative is positive. Okay. And if you do your math and enter in your calculator, you find out that's not getting any simpler. So we just leave it. Okay, and we're good. Okay. So, couple of things to ponder here. So, least common multiple. There are several ways to find this, but we're going to kind of chat about how this works here. Least common multiple means if I were to take, in its kind of simplest form, if I said, okay, here's 4 and here's 5, I'm going to list off all these multiples until I see they have one in common. So I could do it by counting. I could do like, okay, so 4, 8, 12, 16. I'm going to start a list here. And then with 5s, count by 5s. 5, 10, 15, 20. Now notice I don't have any numbers to do the same on both lists yet. So I'd keep my list going a little further. And once I get to that next number on 4, I notice 20 is there. To which the question normally comes up. Well, Mr. Hardy, 4 times 5 is 20, so why can't I just multiply them together? Sometimes that works. Sometimes. Okay? For our purposes, if you're doing it in a problem, you could do that. It just is going to make your numbers larger. Okay? But as you're going to see here in a second, that's not going to work every single time as far as an LCM goes. So let me show you one where it wouldn't work. So 2, 3, and 4. Wow, we got 3 lists this time. Okay, let's do what I did before. I'll just start with like 4 of each here. 3, 6, 9, 12. I'm like, ooh, so far I got 6 in both of those. If I get a 6 in this last one, I'm good. Of course not. Okay, so I start looking, and I'm like, okay. So 6, no. Now I see 12s there. Let's keep going to my 2s. And if I go a couple more, I notice 12s in all of them. Now, 2 times 3 times 4 would be 24. It would be large. It would be a common multiple. If I kept all these lists going, 24 would be on all 3 lists. But it's not the least. So whenever you see least, we want to get that simplest one. And the easiest way is to just kind of count out like this and go there. Unfortunately, not a really good way to do it in a shorter way than that. So why would that LCM thing be important? Well, when we get back here, multiplying the entire equation by the LCM will eliminate denominators. Now, if some of you are comfortable with fractions, go for it, okay? I know a lot of people aren't. So again, I'm going to show you, I'll only do it on this first one because I don't want to drive some of you crazy. Sometimes I can do overkill on this, but I want to make sure you get a way that works for you. If I were to work on finding my LCM, 6, 12, you're like, wait, can it be the number? It can. Okay, so my LCM here would be 12. So what I would do is I'm going to multiply this entire equation, even the part that's not a fraction, by 12. Okay? So 12 times x is 12x. Okay? With the fractions again, it's multiply by what's on top, divide by what's on the bottom. 12 times 5 is 60, divided by 6 is 10. If you're like, whoa, don't necessarily want to go that way, Hardy. Here's options you have. 12 times 5 divided by 6, you can do that. Or you could just do 12 times 5, 6. Okay? Any of them are going to get me 10. Just make sure you don't lose the minus there. And then here, I think we can handle this. 12 times 1 is 12. Divided by 12 is 1. Just like that, bang, back to a normal looking problem. Get our x by itself. Divide by 12. Because again, that's the opposite of multiply. And if I went to my handy dandy calculator, that would be my simplest fraction version of it. So you're like, okay, you'd said there is another option. There is. If you wanted to, you can multiply your denominators together. Okay? So if you're going to go with the multiply denominators plan, would that work? So if I do that, I'm going to be multiplying everything by 72, because 6 times 12 is 72. So what would be different about this if I went that route? Now, if you are perfectly comfortable with what I did on the first part, you can fast forward me through this part. But if you're like, this is intriguing, I don't have to do that work now, I just multiply them. So I would distribute that through. So 72x, now let me just show you a couple of things here quick. So 72 times 5, 6 is 60. And 72 times 1 is 72, divided by 12 is 6. You're like, okay, these don't look the same. Oh, but just watch till the end. Stick with me. Plus 60 plus 60. You're like, I don't know. This ain't looking the same. Divide by 72. Here comes the moment of truth. You're like, Hardy, not the same. Oh, are they not? Let's see. 66 divided by 72. Remember, simplest fraction. Math, enter, enter. Hey, hey, hey. Haven't lost everything, okay? They both work. Every time, not a fluke. So you pick how you want to go about that, okay? So I'll even mention this on this last one. If I do my legitimate LCM, again, I'm just looking at the denominators of fractions. That 2 is going to be left out of this idea. If I went through and I did my lists for all of these, my LCM would be 20. If I'm going to do the multiply plan, 4 times 2 is 8 times 5 is 40. Both of these would work. It's just going to be bigger numbers, but you've got a calculator, so it really doesn't matter which route you go. Now me, I'm going to go with the LCM because I'm the math teacher and I want to keep the smaller numbers if I can. So again, challenge yourself on some of this. Multiply times the top, divide by the bottom. 20 times 3 is 60, divided by 4 is 15. Okay? You can still go to your calculator if you want to. We just saw that before, which is fine. But you always should get rid of the fractions by doing this. So if you get an answer that's a decimal still, something went wrong. 20 times negative 2 is negative 40. Okay, 20 times 5 is 100. Divided by 2 is 50. Again, in your head, using the calculator, all good. 20 times 1 is 20. Divided by 5 is 4. And now we just have a job of moving x's around and then simplifying. Smaller x value, I like doing it that way. Do my opposite. That's positive 15x, so I got a minus. 50 minus 15 is 35. And just keep rolling with our problem solving skills, with our equation solving skills here. Get that plus 4 out of the way. And divide. And again, we don't do decimals. If you punch in and get a decimal, do math enter enter, your simplify fraction, and get yourself there. Is there any way to do this shorter? Not really. Now, Mr. Hardy, you'd mentioned, if I'm comfortable with fractions, if I'm comfortable, subtracting 3/4 x over here, can I do that? Yes. But if you start to struggle, I would suggest going back to this route and getting the fractions out of there. But if you're comfortable with the fractions, you absolutely can work with them. Okay? I just want to see a step or two again. I don't want to just see all of a sudden, this is the answer, I did it in my head. I can't do it in my head, and I'm old. If I've been doing this for 23 years, I wouldn't do that in my head. So, just saying. All right, last piece. You're like, whew. That's the other thing that's nice about a video. If you just get tired of hearing me for a while, or I'm not doing anything crazy enough to keep your attention, just pause me or come back to me later. It's fine. No rules. All right, writing and using linear equations. For each problem, set up an equation and solve. Okay, so for some of these, we got to understand what we're coming up with here. So I'm going to try something here for a minute. Oh, boy. Here we go. Trying to make sure it can actually get the whole... No, your eyes have not gone bad. We just got to wait a second here. I needed to bring my screen out a little bit further so we could actually see the whole question here. Okay. So a real estate broker's base salary is $18,000. Oofda. She earns 4% commission on total sales. How much must she sell to earn $55,000? Okay. I'm not saying you're going to have to write these out in words first, but especially for examples, let's do it so we can kind of see how this works. So when you're a real estate broker, you're going to get a salary. You're going to get a certain amount of money no matter what. In this case, our real estate broker's salary is $18,000. She earns a 4% commission on sales, okay? That's more money that's going to be in her pocket. So we're going to add that. She earns 4%. Now, I don't just write 4 here. When we do 4% as a decimal, there's a couple of ways to do it. As a percent, you can always do that as something over 100. And if you punch that into the calculator, or some of you know this off the top of your head, you're just moving the decimal 2 places to the left. 1, 2. So that's the number we're going to be using. But we're not just using 0.04 because she gets that on sales. Okay? You can call it S. I'm going to call it X because she gets 4% times however much she sells in real estate. So then, how much must she sell to earn $55,000 total? Probably should put that down here. And that's my equation. So I have to kind of think through this a little bit sometimes, depending on what the situation's going to be. Now, once I get here, it shouldn't be bad. Because I'm like, okay, trying to figure out what X is. I'm adding 18,000 to it. I do the opposite. Don't let the fact that we got words and numbers together just screw things up. A lot of this is going to be some common sense and just kind of working through it in your head a little, which is why I like writing it out in words sometimes. Sometimes the words make more sense than the numbers do. And divide by 0.04. Okay, Hardy's not doing this in his head either. Nope. Too early in the year to be doing this stuff in my head. All right. 37,000 divided by 400. 925. Almost $1 million is going to need to be sold to get that 55,000 that we're hoping for. Okay. But again, practicing on these, and these are ones I can help out with too if we have some issues. All right, last one. You've almost survived. Maybe you've had a little cup of coffee, hopefully not the energy drinks, but yeah, whatever you got to do, just keep it with it here. You have a summer job that pays $5.60 an hour. Okay, first you need to choose your jobs more wisely, but we'll discuss that another time. You get $8.40 an hour for overtime. How many hours of overtime must you work to earn $287? Again, let's think about this for a minute. Okay, so I'm working me some regular hours. Now, some of you may be new to the workforce on this, so we got to chat about this a bit. I'm going to get $5.60 an hour, per hour. So however many hours I work, if I work 10 hours, I multiply that by 560, that's how much I make, okay? It mentions overtime here, which is anything over 40 hours. Now here's how this is going to work. I can't just put X here for my overtime hours. Well, why not? Let's say I work 40 hours. I don't get $5.60 an hour plus $8.40 an hour. That's not how this works. It's anything over 40. So let's think about this for a minute. If I work 45 hours, how many overtime hours is that? Well, it's 45 minus 40. I'd get 5 overtime hours. If I worked 50 hours, okay, how many more hours over 40 is that? Well, 10. 50 minus 40 is 10. So my overtime hours are going to be 40 minus X, or maybe, now let's look at this for a minute. So if I worked 50 hours, 40 minus 50, that'd be negative. Well, that's not good. Okay, order matters. Now, did I do that on purpose, or did I just screw up? You'll never know. Okay, because now I can look and say, well, if I worked 45 hours, okay, I'd be looking and I'd go, okay, let's see here. Hardy, I have a different question for you. Because maybe you're looking at this right now and you're going, well, if I worked 45 hours, that'd be 45 and that'd be 5. That'd be like 50 hours. Well, what do I do then? Oh, wait, my regular hours, if I'm working overtime, for some of you that get picky about scribbling things out, I apologize. I'm just trying to get you to see that sometimes these problems are going to develop, and I'm going to have to think about this a little bit. My regular hours up to 40, I'm getting 560. Since they said I'm getting overtime, I'm assuming I'm working my regular 40 hours. So now this is 40, and if I worked 45, it doesn't affect this at all. It only affects this. So let's take a look at what this is going to look like and see if we can make a little more sense out of this. So I'm going to work 40 hours at $5.60. That's my regular work week. Plus, I'm going to work overtime, where I'm getting $8.40 for every hour over the 40. Okay? Hours 41, 50, whatever, I'm getting this amount, and this is what I'm trying to get at the end. So how does this work? Well, let's see. So 560 times 40 is 224 plus this 840 I've got to distribute. So 840x minus 840 times 40 is 336 equals 287. You're like, okay. Now let's see. Only got one x term, but I have both of these numbers. So let's see here. 840. We got 224 minus 336 is minus 112, 287. And now we're back to a regular two-step math problem. So I got my 840. We're going to add the 112. 399. It's going to run us into another issue here in a minute, but we got this. We can tackle these. And divide by 840. Now let's see what we end up with here. You're like, okay, Hardy, I got a decimal. Now, x equals 47.5. Now, be careful, because we are so used to x being the answer we want. Oh, so I worked 47.5 hours of overtime. I worked 47.5 hours total, but that's not the question. How many hours of overtime? I worked 40 hours of regular, 7.5 hours of OT. Okay? Sometimes I'm going to have to go a little deeper. Now, are all application problems going to have this much thought and twistiness to them? For the most part, no, but I want to introduce them to you so you can say, okay, sometimes I got to think through this. Maybe you'll get an answer sometime. You'll be like, wait a minute, 47.5 hours, that's a whole lot. And you kind of think through it and kind of see how this is going to work. So again, with this particular section, always be looking at your list. Sometimes I may throw in some small things here, like maybe a quizzes quiz, just to kind of see how you're thinking with some of the stuff to work it out. Sometimes we may be looking, okay, again, here's the practice that's right behind it. If you're real good in some things and bad in others, I'm not saying you have to do every single problem here, okay? The answers are right on the back. So I shouldn't just see you writing all these answers in the front. Work a few of them out. Maybe you just start with evens. Maybe you just start with odds. And if you get them all right, I think you're good. You just go on, okay? But if you're struggling, try some out. And if you're still not getting the answer, let me know so I can try to help you out, okay? Great seeing you again here. Keep at it. Keep strong. Keep working at it. We will see you the next time.